Hi guys and welcome back to Maths with Cats. So first thing I want to go over is the fact that I've changed the way I'm doing things a bit. Rather than every other slide having cats on, I'm just going to have a cat in the corner of the screen somewhere, like on this page. Just because that way the problem of the slides being slow to move on won't be quite as big a problem because we won't have to sit there waiting to move away from a picture of a cat. Okay. Second thing, today we're going to be going over inequalities for AQA A-Level Maths. So let's get started. So, first thing, dealing with negatives and inequalities is a very important thing to consider. Adding and subtracting does not affect the direction of the inequality sign. Neither does multiplying and dividing by a positive number. But multiplying and dividing by negative numbers will change the direction of the inequality sign. This is because it's the same as swapping everything from one side of the inequality to another if you're timesing by a negative. So, if you've moved everything to the other side, the sign will be facing towards the opposite side, if that makes any sense. I feel like I explained that badly. Okay, so here's an example. Find the range of values of x that satisfies x minus 3 is less than minus 1 plus 2x. So, if we add 1 to both sides, you end up with x minus 2 is less than 2x. And then minus x on both sides, and you get minus 2 is less than x. So you can see from that, adding, subtracting by positive or negative number does not change the sign. Next example, find the range of values of x that satisfies 8x plus 2 is more than or equal to 2x plus 17. So if we add minus 2 on both sides, 8x is more than or equal to 2x plus 15. Then you can take 2x from both sides and get 6x is more than or equal to 15. Divide by 6 on both sides and you get x is more than or equal to 5 over 2. So you can see from that one, dividing by a positive number has not affected the sign. We've also used adding and subtracting again. Yeah, we've used subtracting again. Not affected it. So another example now. Find the range of values of x that satisfies 4 minus 3x is less than or equal to 16. So if we add minus 4 on both sides, you get minus 3x is less than or equal to 12. If you then divide by minus 3, you get x is more than or equal to minus 4. Because if you think about it, a different way of rearranging this would be to move the 3x onto this side and minus 16. So you'd have minus 12 is less than or equal to 3x. If you was to then divide by 4, you'd end up with minus, what am I doing? Divide by 3, sorry. You'd end up with minus 4 is less than or equal to x. So that's why you have to flip the sign. So you end up with the same thing. Some places, and this is probably a safer method in case you forget to flip, always try and get a positive x when dealing with inequalities. That's what I always aim for. It just avoids that. And when I say try and get a positive, do that by moving the x to the other side rather than dividing or timesing. My personal method. But you can also do it this way. You just have to remember to change the sign. Okay, so another thing you might need to know is how to sketch to solve. So here's an example. Find the range of values of x that satisfies 36x is less than or equal to 6x squared. So you want to get everything on one side. So we've minus the 36x here to get 0 is less than or equal to 6x squared minus 36x. That's the same as 0 is less than or equal to x squared minus 6x. We're then going to sketch y equals x squared minus 6x. So if you sketch it here, I've put the x equals 6 here to mark the root. This root's just at 0, which is why I didn't mark it. And you can see here, so 0 is less than or equal to x squared minus 6x. When y equals 0, we have the x-axis, first of all. And if we want x squared minus 6x to be more than that, it's going to be above it. So it's this section and this section we're looking at. So, yeah, that's what I've just explained. So if you look here, because it's a U-shaped, the bit that's above the x-axis is to the left of this root and to the right of this root, because you need the bit that's where the line is. So solutions are x is less than or equal to 0 and x is more than or equal to 6 to get these bits. Set notation is important for this because you might have to give your answer in set notation. Set notation uses curly brackets. So here's an example. This here is the set of values of x where x is less than a. So if you're not using set notation, you would leave out the brackets and the x column, and that's the same thing. This symbol here, I don't can't remember what it's actually called, but it's an empty set. So if I was to write this, that would mean there are no values of x where x squared is less than 0, which we know to be true because you can't square root a negative. So that's what that means. Without the equals empty set thing, that's just the set of values where x squared is less than 0. But because we know there's no values to that, we can put it equal to this. So this little thing that looks like a U, it's the union symbol. The union of two sets is everything in either set. So this here means the set of values of where x is less than a, or the set of values where x is more than b. So you can write it as this when you want to separate it: x is less than a, or x is more than b. N is the intersection. So these are the points that are in both sets. So it doesn't cover any of the points that are in either set, only the points that are in both sets. So the set of values where x is more than c intersected with the set of points of x which are the values of x where x is less than d is the same as x is more than c and x is less than d. Brackets can also be used in set notation. So if there's a round bracket, it means it means not equal to, and if there's a square bracket, it means it can be equal to. So round bracket 3, 5 square bracket means 3 is less than x, which is less than or equal to 5. Okay, so this is an example of two inequalities, and I've just realised I forgot to put this in the annotation pane, but anyway. The first step, draw and label the region, the example. Draw and label the region that satisfies y is less than x squared minus x squared plus 2x plus 3, and y is more than or equal to 1. So we're going to sketch them both, but with an equal sign. And because the question is telling you to draw and label, you will need to have a dotted line for the first one because it's less than, not less than or equal to. So even though we're doing it as an equals, it's going to turn into our final graph, so we're going to need to use a dotted line straight away. So without all the shading, you would draw the curve and you draw the line, the curve will be dotted. So then you're going to find where the curve and the line intersect. So for this one, it is x equals 1 plus root 3 or 1 minus root 3. You can then test points either side of those points. So using the curve equation, find y when x is a value less than 1 minus root 3. Find y when x is a value between 1 minus root 3 and 1 plus root 3. And find another y value where x is more than 1 plus root 3. And you want to see where it's going to satisfy y is more than or equal to 1. You can also, if you'd rather, use your sketch to see this, because you want to, because of the values here, you want to find the point when curve, where the points below the curve are above y is more or equal to 1. So you can see under this bit is where it's less than the curve, and you can see all this blue bit up here is where it's more than the curve. So this bit here covers both of them. So that's going to be our point. And because that's between the points of intersection, you can see it's actually the middle one. So yeah, for this case, when x is less than 1 minus root 3, y is less than 1. So that's not where we want. When 1 minus 3 is less than x, which is less than 1 plus root 3, y is more than 1. So that is what we want. And when x is more than 1 plus root 3, y is less than 1. So again, not what we want. So like I've just said, it's the middle value. Then the final step is to shade the areas satisfying the inequalities. So this, again, I've used Desmos for the graphs in this. And you can see here, the blue bit is satisfying the bit above the more than or equal to 1. The red bit satisfies the region where y is less than minus x squared plus 2x plus 3. And the purple area, because blue and purple, if you remember, is the area that satisfies both. So that is the bit you shade in the exam. In the exam, I'd also label the points of intersection and possibly the points where it crosses the x-axis. You shouldn't need to label any more than that. Sometimes it'll tell you to like label it, so it might say label it R, so you could put an R in this region to show that. It will state what it wants you to label it in the exam room. So that is it for today. I hope that having a cat in the corner of the page is better than every other page. I hope you found this useful as well. If you did find it useful, can you like and subscribe so that more people can find it? And if you didn't, you could leave a comment with some feedback for me so I know what I can do better to help you guys, because I really want to know what I can do to make life easier for people. Hope you enjoyed. Bye bye.